Hi everyone, welcome back. In part 2 this week, we're going to take the character that we built in part 1, our little ninja character, and we're going to develop a level around it so that we have something to play within and turn that into a little bit more of an actual game. Okay? And what we're going to use to do this is we're going to use an object in p5play called tiles. Okay? So let's jump over to the documentation real quick. Now the tile page is pretty sparse. Okay, so we'll do some kind of a more elaborate example in this video. But what tiles allow you to do in P5play is it solves the problem of being able to design more intricate levels for your games. Now normally a more in-depth, full-fledged game engine will have tools that allow you to drag and drop, sprites and build levels using that kind of interface. P5play is meant to be a simple game engine without too many bells and whistles. So the tiles object is kind of a nice compromise between not having any tool at all and having the ability to do kind of basic layouts for our levels. The way that it works is that you create different groups of objects and you give them a label. So in this example on the documentation, we have a brick group and the bricks are given a tile label of equal, the equal character. And then using an array of strings, you can basically define a layout and decide where on the screen your individual group objects will appear. And here the dot or the period is used to indicate a space. So they're able to take this kind of crude drawing, essentially drawn with text, and turn it into a layout for these brick object sprites. So we're going to do an example of this in the game we're developing today. We're going to use the tile object to allow us to lay out different tile types. Okay? And we have a few images that we included in our assets in the beginning. We have a block image. It's a little bit small here. It's only 16 by 16 pixels. We have a gem, which is a single row of an animation sequence. We'll talk about loading that type of sprite sheet as well. A little bit simpler than our ninja, which has multiple rows. Gem only has one row. We also have a platform object, which is just another cube that's got a different look to it. And we have a spike. Okay? And using the tile object, we'll be able to create a level layout with a combination of all four of these groups of sprites. Okay? So let's go into our sketch here. And we're going to start off just by creating a few variables. Now, just to demonstrate, we're going to build a simple little layout with just our basic ground block here, and then we'll add more detail to it as we go. So we're going to need to create a few variables to start off with. So first we'll have let's make a variable that's going to contain the image for our block. And we're also going to make a variable called blocks, which is going to be used to represent the group that we're going to define in P5play to represent the blocks. Okay? Now in preload, because we're loading an image, we're going to do that in preload. We'll say block image equals load image block.png. So again, this is a little 16 by 16 image of a block. And then in setup, we're going to go and define our group. We'll say new group. So the blocks is going to be a new group in our code. We're going to set blocks.image equals block image. And we'll say blocks.tile equals b. Okay. So whenever we use the character b in our level array, we'll be able to position, kind of place some blocks, which will be a lot easier if you want to build a more complex level than just having to manually figure out the XY coordinate of all of your individual game objects. And then finally, our blocks, we're going to give them a collider of static. So these are meant to represent kind of the solid ground of our level. So they're going to have a static collider just like our ground sprite here that we created just as a placeholder to have something to run onto. Okay. All right. Now, now that we've made a block, our group for our tile, we are going to go and design our level. So we're going to make an array here. I'm going to call it level. And the idea is that this array is going to take strings, okay? And then inside these strings, we can put blank for having like blank space, right? Let's say we are drawing a simple little array here, a simple little level that looks like this. And then I could go into this array. I'm going to hit the insert key here, and we could put some blocks maybe have a little platform over here. Okay, so we could do a little layout, a little level layout like this, using each individual string as kind of one row of our grid-based tile layout. Okay? And everywhere I put a letter B, this is going to create a a sprite object from my block group that I made over here. Okay. Okay. Now, once we have our array here that represents our level, we have our block group. We can go down here and we're going to create the tiles itself. Now the tiles, I don't need to put into a separate variable. We're just going to say new tiles because we don't care about the object that gets returned here. This is really going to be about automating the creation of all the individual sprites as laid out inside this array called level. Then we'll say what's the starting X and Y position. So we're going to start in the top left. So we'll say start at 0, 0. And we're going to also say what's the dimension of each tile, each block. And we'll say in our world, these are 16 by 16 pixels. And then let's see what that looks like. Great. Once again, we run into the failed to fetch issue. So let's just go and solve that real quick by duplicating our sketch. Oh, having a little issue here saving the sketch. Looks like the p5.js web editor is down, so we'll just we'll be back momentarily as soon as the editor is up again. Okay, we're back. We had a small glitch here where the p5.js web editor just went offline for a little bit, so we're back. Okay, so let's hit play and let's see what happens when we created these tiles. Okay, so you can see up here, this created our tiles as we specified them in our level, and now our character here is falling down starting from the center of the screen. So let's start out at 0, 0 for our ninja. There we go. So now our ninja is over here, and we can run on the blocks that we laid out for ourselves inside the level. Okay. Now, one thing that will okay, so now that we have this, we can get rid of our ground object here. Okay. We'll get rid of our ground object. I'm just going to comment it out for now. And you'll notice that if I can't jump anymore on those blocks, and that's because in draw here, when we do our player control, we are testing, in order to be able to jump, we're testing with this ground object here. So instead here, we're going to do a check with the blocks. Blocks, again, is a group that represents our block object. Okay? So now I can jump again. You can see we're down here. Kind of got a little bit stuck here. That's interesting. That has not happened to me before. But that's okay. We're not going to design the final level exactly like this. And of course, we can fall off here the map because we haven't figured out the rest quite yet. Okay, so let's let's design a slightly more interesting level here, a little bit bigger. So instead of just having a few rows here, let's go a little bit. We're going to move this down. We're going to add some blank space at the top. Okay. We're going to make 13 rows. Or at least we'll put a few more for now. Okay. All right. So we'll put a few more rows over here. And let's add another kind of element. Can put some more blocks here. We're going to add another element to this this level. We're going to add a platform. Okay, just that has a different look to it, and essentially that's going to be just creating another group type, defining what letter this group is tied to in our level, and that object of that type will get created wherever we put that letter in our level. So let's go and say we're going to make a platform image, and we're going to make a variable to hold our platform group. Now, the reason I want these to be global variables is, again, I want to be able to refer to them later on in the code. At some point, we're going to program behaviors for our platforms, so we want to be able to keep them in their own separate groups. so that we can program different things for each of the object types that we're putting in our level. Yep. So let's load up the platform image. So we'll say platform image equals load image platform.png. Okay, so now we can see we have a slightly bigger level here that we've added extra blocks. And let's go and create a group for this new sprite type we're going to add. So we'll say platforms equals new group, platforms.image equals platform image. We'll say platforms.tile, let's call these P, and platforms.collider, let's put a static collider for now. And now what that's going to give me is I can use the letter P inside my my level here. Maybe we'll put a so now that we have our level, one thing I like to do, again, I use the insert key to be able to erase sections. Let's replace this with a P for platform. Maybe we'll put another platform over here just so we can see what that would look like, just to test with. Okay, we have a bit of a gap here. All right, and now this is our new level design that we've created. Now notice again, if I jump on the platform, I can no longer hit space to jump again. That's because we have to always remember, go back to our player controls, and here we need to check not only if we're overlapping with the blocks, but also we're going to add an or if we're overlapping with the platforms. Okay, so we have two different group types now that we can jump from. We're going to have to make sure we consider that in our if statements that control the jumping. So by itself, right, p5play doesn't really know what these groups should be or what they represent. So it's up to us to program the glue, program the logic between these different sprite objects. So now I have these platforms that if I wanted to, I could jump on. Pretty neat. Okay. All right, let's add a layer of spikes here at the bottom for our when our character falls down through the hole. So we're going to do the same as we did with the platform. I'm going to say spike image, and we'll say spikes. Then we're going to go into our level. Let's say down here, we'll call the spikes, they're going to be the S tile. Okay, and then we'll load the spike image. It's just called spike singular.png. And then we're going to go into setup, and we're going to make a new group again. So every element we want to be able to put in our tile map, we need to define as a group. So spikes.image, spikes.tile equals S, and spikes.collider equals static. So we don't want these spikes to fall down when we create them. Cool. So now we can see we have spikes at the bottom of our level. And we could go ahead and start designing level this way. Okay? So tiles is, again, a rudimentary but convenient in the context of p5play way to sort of experiment with creating more level designs and not just rely on manually having to position all of these game elements. Now let's see, we're going to create a much bigger level for this example. We're going to go and let's create a bigger space over here. So what I want to do is I want to be able to have a sequence of 4 blocks, and then I want to have a gap of 1, 2, 3, 4, 5. Okay, and then I'm going to have a sequence of 4 blocks. Let's copy and paste. I could copy and paste the whole level as I built it before. Actually, I'm going to copy and paste from here. So on a gap of 5, gap of 5, gap of 5, and we'll put a space over here. Then I'm going to put a row of spikes on the bottom. Okay. And then we'll have a row of just blank space. And then we'll put a single platform block in the middle here of our gaps. Okay. You'll see why in a sec. Then we're going to put a couple of blocks on top of the base of the level. So I'm going to put some more blocks over here. then we'll have another gap, another space. So this row has nothing in it. This next row over here is going to have some more platforms. So the next round of platforms, we'll line them up. So I'll have another platform over here. And what I'm doing here is I'm basically kind of creating a more of a vertical level. So the base, the platforms, the blocks are getting narrower as they get taller. And eventually we're going to have platforms after platforms where we can reach up and collect some gems that our character is trying to grab. Okay? So actually, let me just create the space here, and then we can go in and sort of draw our level as we need to. Okay? So we're creating just like a bigger level over here. So we have platforms over there. We're going to have another row of blank, and here we're going to put another platform. I'm going to put it a little bit offset. This one's I'm going to line it up with my blocks underneath. So once we get higher up, we're just going to have narrower platforms. And then in the middle over here, I'm going to put a stable block, stable block, stable block. And let's add just another space here at the top with nothing in it. Okay, so we have a much bigger level. Let's hit play to see what happens. Oh, okay, I just fell onto the spikes right away. So why don't we change that? Our player, maybe our ninja here, instead of starting at 0, 0, maybe we'll start at 16. Okay, so we fall down here. And maybe we'll start a little bit closer to the bottom as well, so we don't have as much to fall. Maybe we'll fall at 72 over here. Okay, down there. Now, one thing you'll notice is that I've created a level here that's bigger than what I can fit inside my canvas. Okay? So my canvas is 200 by 200. These blocks, right? Each of these is 16, 16, 16. So I have 13 layers over here right now. So this is actually, I can see the top one. So there's that. But I can't see left to right, right? I'm definitely exceeding 200. Okay? So the objects are still there. If I fell. The objects are still there, but they're bigger than what my canvas can see. Okay. Let's add between this platform and these blocks, I'm going to put a space. There we go. That looks a little bit better. So I have a platform over here. I have blocks. I have another platform here. I'll have another narrow platform, and then finally my stable blocks right at the top. And eventually we'll put some gems over top here that we have to collect. So we've created a level that's bigger than our canvas. So this is where the camera object is going to come in. So the camera is simply an object we can set in p5play. By default, the camera value is 0, 0, but we can make it follow the position of our player. So let's see what that looks like. We're going to go into draw. Let's go at the bottom here. We're going to update the camera. And we'll say camera.x equals ninja.x. Camera.y equals ninja.y. Now we can see as we move, right, we have this camera that is following our player in the level that we created. So it allows us to create levels that are bigger than our canvas has space for. And yeah, so the camera is simply, we can update its position to update the viewport, or kind of the portion of the level that we get to see in here. Okay? And we can make it follow the player like this. Now, one thing that happens here is that as I don't have level at the bottom over here, I don't have blocks at the bottom, right? And on the left here, I also don't have blocks over here. So one thing we could do is we could constrain the location of the camera so that as we get close to the edge of the level over here, or the bottom or the top, the camera is not going to go too far, right? It's going to stay, we want the camera to stay kind of like, maybe like over here, it's X value, so that we don't see what's on the left because there's nothing. Okay? So we're going to constrain the location of our camera. Instead of making it equal to the ninja X, ninja Y, we're going to constrain it so that it doesn't go too far left, too far right. Okay? Now, in order to do this, we need to know what's the actual width of our level in world pixels and what's the actual height of our level in world pixels. So I counted my number of tiles here that I had, and found out that my actual level width, right, was 556. Okay, so we're gonna say oh, sorry, I'm lost down here. So the camera X here, we're gonna constrain. So we're gonna feed it Ninja X, but then we're gonna constrain it to a number between let's say we don't want it to be less than 100 on the x-axis, and then less than 556 on the right axis. Okay, sorry, on the right. So now basically the camera, right, is getting constrained as I'm on the left. You can see that as I go to the right, I can start moving. Oops, still some funny things that happen. And as I reach the end of the level, right, the camera is getting constrained. So it is providing kind of a smaller rectangle that the camera can move within, so that when we reach the edges of the level, our camera stops moving, but our player can still carry on a little bit further. Okay. So this is actually a little bit less than the total width of my level. Okay, total width of my level I think was 556, but I'm creating a 100 pixel gap on the left and a 100 pixel gap on the right. So you can do some trial and error for these. You can also use the console. Well, the way I came up with these also is just use the console to see what's the X location of your player versus the camera, and then find out what are some good boundaries to set for your level. We can also constrain it on the Y-axis. We're going to constrain it, let's say, so that it's always between 0 and 100. Okay? So that when we are at the bottom, right, now the camera cannot go past 100, so I can climb up the level. That's fine. I can go negative, right? I can climb up the level, but the camera, as I fall down, is not going to follow me beyond 100. So this is just putting some constraints on our camera so that it doesn't always keep the player in the center. Okay. All right. Now, finally, let's add some gems here at the top. So I've made these 3 platforms that are kind of singular here at the top. Let's add some gems onto them. These are going to be the things that we're hoping to collect. Okay. So just like we did with the other group types, we're going to create some variables. We're going to create a variable to represent our group called gems, and we'll create a variable called gem sprites to contain our gem image. Now, unlike block, platform, and spike, gems are actually a sprite sheet. It's a simple sprite sheet. It has 7 frames. Okay, so we're going to load it using this syntax. We're going to say gems sprites equals load animation. We're going to load the animation for the gem sprites, and we'll say this is the image we're loading, gem.png, and that image contains, I'm going to just go all on one line here. We'll define an object. We'll say frame size is 16 by 16, and number of frames is 7. Okay. Let's get rid of that on the side here. Let's move our window over there a little bit. Okay. So this is a little bit simpler. It's similar to what we did over here. This was more complex because we had every row of the file at a different animation sequence, which means we had to label it, tell it which row we were in. Here I'm specifying the frame size over here and the number of frames, okay, and loading that as a sprite animation. So let's go and create our group for the gems. So we'll set instead of setting the image, we'll set the animation to gem sprites. And oh, no S. I don't think I put an S. Shouldn't have an S. Makes no sense. Just correct this. So gem sprite, and gem sprite. Okay. And we'll set a tile to, let's call it G. Okay. So now if I want to include elements from this group, I just go back into my level and I can put G on top of my blocks here. come I have so many? Oh, let's put fewer. We're gonna put only 3 gems. So we'll put one over here. We'll make it a little bit harder too. And let's see. We're gonna put a gem here and a gem here. Okay. So I'm adding gems at the top layer, and then we'll see when we run our sketch. Failed to fetch. Does the asset exist? Yeah, it's there. Save. This is we're having some pretty bad luck here with the P5 editor server today. Let's duplicate this and run it. We have some other error here. Gem is not defined. Oh, that should be gems.tile. So fix that. Okay. So now it appears. Now we have our gems at the top, which we can interact with. They're just game objects, right? We didn't set their collider to anything special, so they can be interacted with. Yeah, so they can be pushed around and so on and so forth. All right. Let me just quickly compare my level with this one. Oh, that looks about right. We can always tweak it later on if we want to. Okay, so now that we have used the tiles to create our level, let's add a little bit of refinement to this to make it more fun to play. So first of all, we're gonna make it so that if we we're gonna give our players some lives, okay, so that if we hit the spikes here, right, I can't jump, we're gonna go back to the beginning, we're gonna teleport back to the beginning here, and we're gonna lose a life. So the first thing we could do is we'll go on our ninja. This is our ninja sprite in setup, and we'll say let's give ourselves 3 hearts, 3 lives. So this is an example again of just adding a custom attribute to our ninja sprites. We can add any variable we want in addition to the ones that are built in. So here I'm going to make up a variable called hearts, and we can use that number here to draw that variable to draw the number of hearts we have available. Okay. So let's see, we're going to go down at the bottom here. Let's see and draw the hearts. We're going to draw them first so we can see it actually decreases when we lose some hearts. All right, so let's we're going to write a little for loop here. We'll say ninja.hearts, and we're going to set a text size, a red fill, and a black stroke, let's say. And then I'm lazy here. I could load up, I could go and look up, get a heart sprite, but instead we're going to say heart character. Okay, let's grab this character over here. We could get an image too, but I'm just going to use the text function to draw a heart, and we're going to position it. We'll say 10 plus I times 14, which is our text size, and then 20. Okay. So this should draw 3 hearts over here. They're a little bit blurry, a little bit kind of awkward because in pixelated mode, right? Unless you have a bitmap font loaded, stuff doesn't look as nice because it basically gets scaled up and gets this anti-aliasing effect. So not ideal, but we'll load a different font in a second that looks a little bit better. So now I have these 3 hearts at the top. And what we could do is we could say every time our player collides with one of the spikes, we could just lose a life. Okay, if we fall on a spike or off screen, lose a life. So we'll put an if statement here. We're going to check our ninja. We'll say if we overlaps with the groups, the spike group, okay, or if our ninja.y value becomes ever greater than 200. In other words, like if I jump off the map here, I'm going to keep falling down. So we never want our y value to be more than 200. So if that happens, we're going to detect it. And if that happens, we are going to say ninja.hearts minus minus. We're going to lose a life. we'll say ninja.x equals 16, ninja.y equals 72. So we're gonna go back to the start. Okay, let's hit play and see what that looks like. So now if I hit a spike, right, we lose a life and we go back to our starting position. If I jump off camera, we also lose a life and go back to our starting position. Cool. All right. Now let's add some code where we can go and catch these gems. Right now, if I just bump into it, the gem just falls off because it's just an object that we can interact with. So catch the gems. We're going to say go and check all the gems that we have. We could also define this as a collision callback, but we're just in the code here, so we'll do it there. So we're going to write a for loop that's going to iterate over the gems group. And we'll say, while we do this, we'll say if the ninja overlaps with one of those gems, we're going to remove it. And then we're going to increase a variable on our ninja that represents the number of gems we've collected. So let's go and add an attribute here. We'll call this gems. So just a variable that we need to keep track of how many gems we collected. Then we'll go back down to this part of the code here, and we'll say ninja.gems ++, just increase the number of gems we've collected. Then it would be nice if we could visualize this somehow. So let's go into our text here. We'll set a white fill and let's draw gems. And then we'll add to that ninja.gems and out of 3 because we have 100 and we have 3 possible gems we can pick up. Okay. And let's give it a location. Let's see what that looks like. Again, the text might be a little bit blurry here, but we'll come up with a better font in a minute to improve this. So now as we go through the level, we can go jump on these platforms. And if I collect a gem, now it's removing that gem from the sprites and it's adding 1 to my gem count. And we can keep going like this. Eventually we'll be able to get that one. We won't be able to get until we animate our platforms, but I could collect the gems this way. And if we lose all of our lives, one thing that we could do is we might want to have to figure out a way to reset the gems so that they reappear and reset our gem counter as well. Okay. So let's talk about that here for a second. So we can find out here as we lose lives, right? As we lose hearts in setup, we could have a little check here that's going to say if we reach 0. Okay, if we lost all of our hearts, we could say ninja.hearts, we're going to go back to 3. We could say ninja.gems equals 0. But the trick here is we need to be able to put the gems that we collected back into the level. Now, this is a little bit tricky because the way that these gems get created is using the level, the tiles. Okay. So the way that these gems appear in our game is on this line over here when we say new tiles, right? And this creates all of our blocks, all our platforms, and all of our gems. And unfortunately, we don't have a way necessarily to say just create the gems by themselves. Okay? There's a couple ways we could do this. One is we could create a separate level that has only the gems, and we could use that, and that has all of the white space down here. We could do that to kind of put the gems back. That's a little bit awkward because I like to be able to see my whole level together like this. So what we're going to do is we're simply going to say, okay, what's going to happen when we die and we lose all of our hearts? We're going to recreate all of those. We're going to delete all the game objects and we're going to recreate them. Okay. Seems like a lot of work, but for the computer, it's not that bad. So we don't need to redefine the groups here. We're going to leave that alone. But we are going to take Ninja here. We're going to take this code for creating the Ninja all the way up to our tiles. And we are going to cut this and put it into its own function called create game objects. I'm going to paste that in here. And I made a mistake when I cut. I'm missing a bit of characters. Okay. Put a line here so we can separate these. And then at the end of setup, over here, I'm inside setup, we're going to say create game objects. All right, so in the beginning of the game, we're going to create our game objects, and we're also going to recreate the game objects when we lose all of our hearts. So we'll go down to draw. When we've lost all of our hearts, we're going to say all sprites dot remove all. So all sprites is the master array that contains all the sprites in the game. We're going to remove them all, and then we're going to say create game objects. So it seems a little counterintuitive to say destroy everything and rebuild it from scratch just so we can get our gems. But as far as the program is concerned, this is not really a lot of work. This happens really fast. And so here I'm going to just demonstrate. I'm going to lose. Actually, I should pick up one of the gems. There we go. So now I have one gem. I have one heart left. So if I fall onto a spike, see, I've lost all my lives. I go back to 3 hearts. And the gem has come back over here. In fact, what happened is we deleted every single game object using all sprites removal, and then we just put everything back just the same as we did in setup. So we're kind of like, oops, starting fresh every time. So that allows our level to get recreated again with new tiles, and that in turn recreates all the platforms, all the blocks, and all the gems. So that's the way I chose to solve that particular problem. Again, we could have also made a separate level containing only the gems so that we could have left the platforms in place. Seems like more work, so this seemed a little bit easier for me to approach it that way. Okay. All right. Now the last few improvements we're going to add to this game, because this video is starting to get a little bit long, okay, is we're going to make this game a bit more fun to play by adding a behavior to our platforms. Okay, now that we created these platforms over here, we're going to give them a behavior so that they can be animated, just make the game a little bit more fun to play, so that not everything is not static. Okay? So the way we're going to do this is we're going to write some code that's going to get the platforms to move from left to right. But just to make it a little bit more interesting, we're going to randomize their starting direction. Okay, so here we're going to go inside our create game objects, and after we've built all the tiles, okay, we're going to go through our platform group. Okay, we're going to write a for loop that's going to iterate over all the platforms we created, and we're going to define a few attributes, a few new attributes for each of these platforms. Okay? We'll say the platform, we're going to add a left value. Okay, so that's going to be 32 less than the platform's x value. Okay, what that means is that this is going to define a value on the left, that kind of a boundary that the platform can go to when it moves to the left, using its starting position as the reference point. Okay, and then we're also going to define the right boundary by saying take your x value and add 32 to it. So 32 is like the space of like two blocks. Okay. All right. And we'll give the platform a velocity of 1. Okay. By default, we'll say our platform is going to have a velocity of 1. And then once in a while, okay, so we'll throw a random number and we'll flip a coin. So this is a way to flip a coin. We'll say if a random number between 0 and 1 is less than 0.5, that's going to happen half the time. We're going to take the velocity of our platform and we're going to multiply it by -1. We're going to flip the sign here so that half the time the platforms are going to go to the left instead of to the right. Okay. Now, because we set a velocity here, you'll see if I hit play, they don't actually get animated. And that's because my platforms right now, if I look at the group, their collider is static. So static objects, they stay in the scene and they don't move. Okay? The only way to move them is to go and directly change their XY coordinate. If you want the velocity to get applied, what you can do is you can define the object as kinematic. Okay? So that's going to create platforms that can move by physics, but that are not going to get pushed around when the player jumps onto them. So now we can see our platforms, they all started moving in different directions. So what we need to do is add a little bit of code that's going to take into account these left and right boundaries and reverse the velocity of the platform once we reach the boundaries so that they can bounce between the left and the right value. So let's go into draw and somewhere in there, let's call this platform behaviors. We're going to go and actually let's do this at the beginning of draw, because our platforms are gonna affect our player control as well. We'll say platform behavior. Let's say if, well, first we'll write a for loop. We're gonna go through all the platforms. So I'm using P here for short because it's easier. We're gonna iterate over the platforms and we're gonna check. We'll say if their x value is less than their right coordinate, greater than their left, less than their left coordinate, we're going to reverse the velocity. Actually, if it's less than the right, less than the left, sorry, or greater than the right. So in other words, if we've reached the left side of our boundary, or if we reach the right side of our boundary, we're simply going to say take the velocity of the platform and multiply it by -1. Okay, so that's going to cause our platform to bounce between left and right limits. Okay, so let's see what that looks like. So now we can see our platform are moving at a speed of 1, and if we reach left or right, the velocity gets reversed. Now, interestingly, what's going to happen if we jump on the platform, okay, our character is going to fall. Now it's going to be a little tricky. We have to follow the platform around, and this is really, really difficult to do. So I would like to make it so that the collisions are not perfect, but I would like to make it so that once I jump into a platform, I want my character to follow the platform around. Okay? So we're going to add some code that allows us to do that. Make the ninja stay on the platform as it moves. Okay, putting little comments so remember what these behaviors are for. So to do this, we're going to take a look at our ground sensor again. Sorry, at our ninja sensor. Right, we have a little object here that we check. Remember, we have our sensor to see if we're overlapping with the blocks and platforms. So we'll say if ninja sensor, if we're overlapping with the platform, with this particular platform P, okay, then what we're going to do is we're going to look at the platform's velocity, and we're going to add the velocity to our ninja's velocity, so that our ninja is going to move by the same amount as the platform. Okay? So we'll say ninja, we're going to add the velocity of the platform to the position of our ninja, not to its velocity, because that's going to cause it to like fly off. So we'll move the ninja by the same amount that we're moving the platform. Okay? So the velocity of the platform is usually 1 or -1. So if our ninja is touching the platform, we want to move its position at the same rate so that it will follow it around. So if I jump on it now, we'll be able to see that our character is following the platform. Interesting. Character is moving around a little bit. Didn't do that in my other version of the game. Wonder why that is, but it's good enough for now. Okay, so it allows us to be able to jump onto these platforms and not fall off. Okay, all right. Okay, so what else do we need to add to the game at this stage? The last thing I'm going to do is I have a font here that's going to look a little bit better than the default font called joystick.otf. So I'm going to go and load this font here really quickly. Just call it font. In preload, we're going to say font equals load font joystick.otf. It's more like a pixel looking font. It's still not a true bitmap font, so it's going to look a little bit odd still, but it's going to look better than the default font anyway. In the beginning, we'll say text font, just to change the look of our font. Oh, sticks with an X. Interesting. What are these characters? Okay, I guess when I copy and pasted, there was some other hidden characters from the little heart thing here. And let's move our let's make the text smaller for the gems. Okay, we'll make this 10 for the gems we collected. There we go. Fits a little bit better on the screen now. And yeah. Okay, so there we have it. We have a simple little platform game, right? We use sprite sheets to create the animations of our player character. We use tiles to create the map for our level. And we saw that we can even program some behaviors from those objects. Once we've created them in the game, they just become sprites like any other sprites. And because we store the blocks, the platforms, the gems into different groups, we can go in and program different behaviors for each of these. Same thing, spikes. When I hit the spikes, something else happens. Now, obviously, this video is getting a little bit long, so we're going to leave it at that, but I just want to point out some other things that we could do here. You'll notice the hearts are appearing behind the blocks. That's because we're not disabling the auto draw for all the sprites. So if we wanted to, we could choose to disable that as we've done in the other videos, and then choose specifically at what time we're drawing the sprites. Maybe that would have to happen before we draw the hearts, okay? So that the hearts can appear on top. We could also add an intro screen and a game over screen and that kind of thing. We've done this in the other two game examples that we've developed, so I decided to leave it out of this one, but if you wanted to, you could program that as well. Instead, we're just simply resetting the game when our character dies. When we run out of hearts, we lose our number of gems, but there's no winning screen right now. When we reach, it'll simply say 3 out of 3 gems. It is possible to do. I've done it. I'm not going to try to do it on camera right now because it is a little challenging sometimes, but it can be done. Okay. All right. Hopefully you found that lesson interesting. We're going to leave it at that for this video this week, and we'll see you next time. Take care.